Hi, good afternoon, I guess, everyone. My name is Tenzal, and this is Scott Matsumoto, and we'll be talking about threat modeling and how we apply this new approach at Intuit. Many of you may not be familiar with Intuit. Basically, we are an American company. We do a lot of tax preparation software for the US and Canada, and we do a lot of small business kind of applications like bookkeeping, pre-accounting.
Personal finance, man. It's like my whole life is run.
And Mint. Many of you may be heard about Mint.
Yeah.
So this is Scott.
I'm Scott Matsumoto. I'm a principal consultant at Cigital. I'm sure you've heard of Intuit, and I doubt you've heard of Cigital. I mean, billion-dollar company. Well, we're private, so we can't even say, but tiny little company. Okay.
But these guys are the thought leaders in this industry. So yeah, so we'll share our experience about threat modeling and how we get to where we got to.
Yeah, I think what we're gonna talk about, so you can see the agenda. So the background is that Intuit had hired Cigital to come in and take a look at what they were doing around threat modeling. There was a whole bunch of, there were about 3 different versions of threat modeling going on in the company, right?
Yep.
And so we came in and took a look, and this whole thing about unifying it was trying to create a model that would work for these different groups. To do so, we're going to talk about, so the meat of this thing is really in the lessons and takeaways for this talk, because you all probably have some kind of threat modeling process or practice within your organization. And so the lessons from Intuit, Tim and I thought would be very valuable to help you guys mature that. To do that, we're going to talk a little bit about that system threat modeling thing. So we're going to talk about the process a little bit, just to make sure that everybody's on the same page. Then Tim will do really the lessons from Intuit. The protocol threat modeling, it's something that kind of came out of the work we did with Intuit. They did there was a very specific type of thing that they did around different protocols, sequences like startup sequences. So we applied our various techniques to that. So you'll see that. And I think that's kind of cool. And then we'll just kind of wrap it up, and then you can go to lunch.
Yep. So yeah, so let's get started. So a little bit about background about this.
Oh, I already did that part. Yeah, sorry.
Yeah, so Intuit had been doing this threat modeling in a different ways for many years, but probably the most common approach that we had used in the past is, of course, Stride. And that's not surprising because we hired one guy from Microsoft, and he worked at Intuit for a while. We got a lot of these practices. And of course, when Microsoft had this threat modeling book and all the mind share about it. So we started doing the Stride approach. And any of you not familiar with Stride and what it stands for? Okay, so Stride.
Oh, you're going to have to do that. We're going to do that. No, we can't get. Come see us afterwards. We'll do it.
So from Stride, that we find out that Stride is too time consuming. Not every dev team has like data flow diagrams, and a lot of times the web applications and stuff that's not quite applicable or time efficient. So we kind of diverge from Stride to more streamlined approach, or we just call it homegrown number 1. And then they're like system guys who wanted to do like slightly different, but their thought process is about the same, but the assets that they're protecting are different. So we came up with Stride homegrown number 2.
Yeah, we came in, we looked at it, and there was, like I said, the approaches were very different. Stride was really the incumbent. It's the Microsoft-based approach. But I think the goals were, from your boss, Rinky, was we want one way to do it across all teams. So these were different parts of the organization doing it differently. And I think one of the things that came across as we, being consultants, you have to go in and you interview and you talk to them and you tell them what time it is based on what time's on their watch. They're like, create the shared vision. But I thought, well, that was kind of a kooky statement. But really, at the end of the day, what you do want to do is you want to create a shared vision with the development teams so that the development teams are bought into the things that you're going to say in your threat model that they need to fix. Okay.
Yeah, so we also wanted to have a common language and common set of diagrams and common template for doing this. So, that's workable across different business units and different product lines in the company. So Yeah, so we're going to talk about, definition of the, so this is the program elements that we have at the Intuit. So our first goal is to, define the process, define this, what we end up calling the unified threat modeling. That's unified inside Intuit, not necessarily that industry-wide. And then we started with having that training, formal training material, and started conducting training. So these two are done. And then our bosses challenge us with like, what is the return on investment? How do we measure the metrics on these threat modeling exercise? So we're working on that. And also, Intuit is a multi-business unit, multiple business line company. So how do we scale this across, these multiple locations, multiple teams with, in an efficient way? So that's what we keep working on these days. So we're going to start talking about, I think this is your slide.
Oh, this is my slide? Okay, so the threat modeling approach. Oh, right, yeah. Okay, so we built a lot of this based on our Cigital process, but we adapted it quite a bit for Intuit. So the first thing is defining the scope. One of the things we found out is that people would threat model the entire system, and yet the development team was only changing one particular piece. So that was an important piece. Modeling the threat structure, looking at assets, things you're protecting, the controls that are protecting those assets, and then looking at the attacker profiles or the attackers for that. That was straight out of the Cigital threat modeling process. The other thing that we did with Intuit, and it was really important, was there was a requirement to use the existing development artifacts. Their development teams actually created a lot of models. They were pretty advanced in terms of your use of RUP, right?
Yeah.
So, one of the things about Stride is that you have to create data flow diagrams. And that was one of the things. There were a couple things that the teams were struggling with. One was having to create other diagrams where all of these artifacts already existed. So one of the requirements was reuse whatever development creates to the extent as possible. And then, and like I said, the other thing was to scope it down. So the part that came out of it was, the system threat models were pretty much what you kind of will see. If you use Stride, you're used to seeing them as data flow diagrams. You figure out where the attackers are. But what we found is that the system gives us a really nice idea of where the various software components are, the relationships between them, and then where are the attackers and controls and assets. And we'll get into these are tiny little pictures, and we'll kind of do bigger pictures of them a little bit. But oftentimes what we find is that between any two components, there's a line in the system diagram up on the top. And often there's message exchanges. For distributed systems, there are often message exchanges and very complicated sets of exchanges, either because it's a startup sequence or it's because it's a formal protocol. And Intuit had a lot of common components. They had authorization components. They had startup sequences, for starting up various kinds of infrastructure pieces. And so looking at the detail of those sequences, protocols or sequences, was another thing that they did a lot of. And so what we did is we adapted. The top diagram is kind of RUP-like. It's pretty much a component diagram with some additional flow control in there. Then for the protocol threat model, we used a sequence diagram, which was a nice representation. It was a representation that the dev teams were already using for designing the protocols, and we took that and we added the threat structure to that, and that's what we came out with, a kind of a different technique for threat modeling for that particular type of problem.
Yep. So let's dig a little deeper into what the system threat modeling means, right? So based on our experience and also experience at Cigital, a lot of development teams, they don't have the data flow diagram per se like the Microsoft prescribes, but they do have a lot of diagrams like that, right? At the least, they have this deployment model, deployment diagram, because they have to tell operation folks like, hey, I want this software to be deployed that way. And they do oftentimes have like the layer model, logical model, all these software components. So we we base our exercise on that, and from these type of documents and information that we have to come up with this thing called the term is the simplified system model, right? This is a drawing of this software system at like where the components are, how they interact with each other. So you see these boxes, like these boxes are the software components, right? The app server and the web server, and then they're of different shape, right? So that what that means is like some of them are in scope. That means that we'll dig deep into that component and threat model it. Some of them are out of scope. So that means that we know that that system exists, but we don't really care about the security implications of that. And some of them are out of partially in scope. So what that means is that we don't really go do the full threat modeling for that component, but we do care about how we interact with the component. So that would be something like the SSO may be partially in scope, and also like the forum software that in this twice system that we use for the class, they use the we use the V bulletin as an example. So that would be the that would be partially in scope because we do care about how we interact with them. And then we draw these what they call the trust boundaries. That's pretty much the same as a similar approach to Microsoft, but these trust boundaries are usually based on the network boundary. So we have the data center, internet, and we can do like the restricted part of the data center. We can put like the corporate network and so on, depending on your architecture.
I think there are builds in this one.
No.
So this one shows, so the builds actually show where, from those previous diagrams, where we extracted the different parts of them in to create this simplified model. One of the things that we found that we're finding out at Cigital about threat modeling and scaling it in our organization is that this is the hardest part. The system analysis is figuring out how all these things fit together is really one of the key things that you have to have staff do and teach them how to do. It is probably one of the hardest things to do as well. So
it is the same experience at Intuit as well. Even the experienced software architects, when they extract this kind of information from what they have, it's a judgment call sometimes, like what kind of scope we want to apply, and also how deep we want to go in. So this is the first step that we come up with.
But the nice thing about this is that we're using those diagrams that they already know about. So we're already building a common language between security and development. I think that's worked out pretty well for you, right?
Yep, it does. And the next step that we do is like we put these labels like assets and security controls and attacker profile. So what are the assets, right? So assets are anything that you want to protect. That's as simple the definition as I can give. Right, so assets usually can be of asset types, like specific assets, like the data or your compute resources. But assets can also be capabilities, right? So some functions that need protection. So a lot of people, it's easy to understand data as an asset, or the network as an asset, the computer as an asset, but some of the capabilities you have a hard time coming up with. So I give the example of like, hey, what about your open mail server, open mail relay, right? So that you may not think of it as an asset, but if that relay can be abused and people using it to send spam, then your IP address could get banned. So that's an asset that needs protection. And in this case, we're protecting the reputation of the IP address underneath, but you have to recognize it's easier to get to that through the capability. And then we think about attacker profiles. So the term here, we don't use attackers, we use attacker profiles, because the attacker your profile can be different based on where you are in the network, where you're in the trust boundary. So I'm a person and I'm an employee at Intuit, right? But when I'm sitting at home, when I'm not connected to any Intuit VPN or anything like that, then I will be just an anonymous hacker on the internet. I'm just someone with an IP address. So that's one profile of an attacker that we put it in the list called the canonical list of attackers. So second is like, I'm really motivated to hack a system. So what can I do? I can get an account. A lot of times I can sign up for an account with very little or very minimal fee, or even if I have to pay like $500 to get this account, if I'm motivated, I'll sign this up. Then my attack profile, although I'm the same person, my attacker profile is different now, right? I'm now an authenticated user to the system. So that's another attacker profile that we put in the canonical list of attacker profiles. And then I'm an employee, I go to work, and then I'm on my corporate network, and I have a different level of access to the systems. And if I were a sysadmin or a network admin, then I have a different level of access to the system. So these are the different attacker profiles. And what about if you use cloud, right? The cloud computing. So the cloud provider may be an attacker, right? He may be a malicious cloud provider who has access to your system and data.
Yeah, and so I think the other piece is the security controls. And I don't know how many of you are here for Mark's discussion about CSP, but that's a security control. And I think we often forget to add in the controls, because for the threat model for us it's the residual risk. It's the value of the asset, the controls that you have in place. So we want to make sure we have those already. And then it's juxtaposing that threat structure against the system structure.
What is juxtapose? I mean,
Yeah.
I don't see the word every day.
Yeah. So Tin yesterday we were going through the slides. He goes, "I hate that word." And then one of our guys that he runs our architecture practice. He has literally gone through all of our slides and taken the words juxtapose out of every single slide. So juxtapose I think that's really what it comes down to, man. It's like you're looking at the system structure, and you're going, I got this, and this is what I'm trying to protect, and so the security structure, and you're really trying to play them off one another, against one another. So I know that in the States we've gotten rid of the SAT words. I don't know if you guys are, like, do you have SATs here? No. Oh. But anyway, all right. So we'll save that one.
So yeah. So we get that, and we identify these assets and attacker profiles and security controls. So what we do next is put these labels on the system, right? So where are the assets? What are the assets and where do they reside? So, and the same asset can be of different places, right? So here, something like the member-only content, maybe a different thing. Session IDs or the credentials, session credentials can be on these connections, or they could also reside in the system. So we attach these labels, and then we do the same thing for the controls, right? And the thing that we really emphasize the control is not to make these controls up. So when you're analyzing a system, you really find the controls that do exist in the system and put it there. You don't put the controls that should be there, you put the controls that are there onto the diagram.
Right, and I think that one of the things we found is that the developers are really good at knowing where the controls are, because they've implemented them, or
Right.
they're designing them in.
Right.
And so this part of the system, a lot of it can be done by the developers.
Right, or at least they have a lot of information.
Goals, right?
Yeah. And then we attach these attacker profiles. And you might notice that attacker profiles are attached to these trust boundaries. Right, so here we put the user machine in one trust boundary, the local LAN in another trust boundary or trust zone, and the internet and data center, because that depending on where they are on the network, different point of view to the system.
Right, and when I think we struggled at Cigital with having a common definition of attack surface. And by physically placing the attacker profile on the diagram, it helps us understand, or at least help me create a common language around what is attack surface. Because attack surface are all the APIs and entry points that the attacker can actually have access to given their location within the scheme of the system.
Right, and then we trace from the attacker profile to the assets, right? So from APO2, how can I get access to one of the assets? And what are the controls that are in there? What are the controls that are not in there? What are the controls that are there, but I can easily circumvent?
Yeah, I think we're just like.
Yep.
So that's this slide.
That is this slide.
Yeah.
So our goal is to record the missing controls or the weak controls, and they go into what we call the threat table.
Yeah. So you're actually going to go through there. One of the things, though, I think that came out that we didn't put in the slides. So those actually slides were from the training that Tin talked about earlier. That was like I think that's one of the key things of their program. One thing that didn't come out, though, is that we didn't include in the slides. The goal of these slides was not to teach you how to do this today. It was just to kind of level set. But is really the notion of canonical attackers. So you have a set of pre-baked attackers built in. And then I know Shannon is one of his colleagues, have been looking at the idea of taking these diagrams here with the attackers, the assets, the controls, especially around the controls, and pre-building, we're calling them blueprints. So, if you think about, you're trying to deploy something, say you're trying to do a deployment on AWS, and so something kind of new, you could actually create these pre-built, models that have the system piece components. They have the canonical attackers. They have the assets that you can see, across the organization, and the controls that the organization has. Because like the security organization has, like pre-built authentication and authorization components.
Right, and that works for the software side as well. If you have like the template, so that's part of our exercise to how to scale this across the enterprise.
Yeah, exactly.
So
the blueprints will help us scale, I think.
Yep. So one of the, I want to share like, what we have learned from applying this, new approach and what, about teaching. So one thing is about classroom, and another thing is about, what are the challenges that we faced, and also what are the wins that we had, right? So classroom, what works for the classroom is that we have this self-contained course, right? So you show up to the class as you are, and we give everything to the, in the class. So we have our printed charts, and then, we have all the handouts and the slides and so on. And we didn't give anything away in the beginning, but so, we keep some of the surprises for the class. And also what helps is that we group the students together into different groups. So people who show up, like they might have different backgrounds. Some of them are dev leads, architects, coders, testers, operation folks, DBAs, and a few security people. We form like small groups of like 4 to 5 people into different, with a different skill set, and we have them work together to solve this problem. It's a very good team-based problem solving, and they learn from each other's strengths and weaknesses.
Right, this is a learn by doing, because I think that's the other lesson that we've learned at Cigital is that you learn this by doing it. You can't read a book about it. The technique can be described very simply. I mean, you could see on there, we can describe it in 3 slides. But actually doing it, applying it to a system, there are a lot of judgment calls. I kind of liken it to learning how to drive. There are a few gray hairs here. So I'm sure you have kids. Anyone who taught their child how to drive a car? Who? Oh, come on. I'm the only one here? All right, one more. Seriously?
Well, they do have good public transportation here.
Oh, okay, that's true. So in the States, where everybody has a car, we have 10 of them, okay, per household. Teaching your child how to drive is like one of the rites of passage of fatherhood, right? So, you can describe how to drive a car pretty simply. You step on the brake to stop the car, you put foot on the gas, you turn the wheel. Okay, so if you've ever driven with a learning driver, you'd think stopping a car was an easy thing to do. Well, every time with my daughters, the first time they go out, you say you put the foot on the brake and then you ease it off, right? That's how you stop. Every time. How many times like boom, boom, right?
Well, the same thing with the threat modeling, right? The concept is really clear. There are only 3 parts involved, like attackers and assets and the controls, right? They're just 3 things, like the gas and the brake and the steering wheel in a car. But there's so much theory that you can explain, but that really you have to get into the car and you have to drive it, and you drive it in the parking lot first, and then you get onto the roads and the freeway. We call it freeway.
And the training really does that, I think.
Yeah. And the one other mindset difference that one example that I want to point out is like when developers think about the system, they think about the assets first. And when security engineers are in that group, they think about attackers first. So, you can see the mindset difference. So some of the challenges that we had, the term threat modeling itself, it sometimes means different things to different people. So every time before I start the class, I ask them like, what does threat modeling mean to you? And 80-90% of the time, they have different meaning of threat modeling. So the term, getting everybody on the same term is a challenge. It's like a foreign language to a lot of people. And the time commitment, we do that as a 1-day training for about 7-8 hours. So for a lot of busy people with the deadlines of projects, committing a day out of their schedule is pretty tough. And another challenge that we have is like when security goes in and leads these projects, and the threat modeling gets done. But we've been hoping and pushing the development side to take the lead on it, and that has been still an ongoing process.
Well, you're still in the middle of that. I mean, that's
this is still a journey.
Yeah, the goal is to have dev start driving some of this and getting as much of the threat model done as possible.
Right, and but what are the wins, right? So the win that everybody agrees on, even people come from different backgrounds to the threat model training, is that it instills the security mindset into them, right? So what I mean is that they learn more about security now. Whatever their baseline is, they do definitely benefit from coming to the class. And second is the alignment of goals, both from doing these exercises in class and also doing practicing the threat modeling. It's like, hey, these are the assets that you know about, and these are assets because they are worth protecting, right? Anything that is worth protection is an asset. So, hey, we have alignment of goals this way. These are the assets, and where are the controls to protect them, right? If they are missing or weak, they know that, hey, you're not protecting it well enough. There are bugs, flaws that can only be discovered by threat modeling, like the design flaws, logic flaws.
Business logic flaws, yeah. I mean, I think like the protocol thing was a great example, of things that, if you're looking at a protocol, deciphering the protocol, all the message exchanges, the message contents, is really difficult to do if you are just trying to reverse it from a black box point of view, or especially if you have the code. And like I said, oftentimes the developers, even just to figure this out, have built a sequence diagram. And so what we've done is so that technique uses the sequence diagram. We annotate it with some other stuff because it's really, a lot of times it's really the messages and stuff inside of that and the crypto involved in protecting that. But again, it's a shorthand, it gets you there, and it gets you earlier in the process.
Yeah, these are the flaws that wouldn't have been detected by other methods like, statistical analysis and so on, right? And also the big win for us is like consistent language, consistent set of diagrams. What we do is that we give out this visual stencils after the class so they can start doing this. And also even the document format, that we have a template for documenting this. So if I have to go in and help, with a new business or new product that I'm not familiar with, at least I have some familiarity with the tools and the format and the language.
And within the security team too. It's just like if you give someone on Shannon's team a document, or if they start it, you guys can finish it.
Yeah.
Yeah, so there are different teams. Within Intuit, there are multiple security teams. I mean, think about it.
Right, that's a pretty big company with multiple product lines. So yeah, then we get back into like details about what the protocol threat modeling is.
Yeah, we'll run you through that pretty quickly because we're getting close to lunchtime. I'm hungry. I don't know how you guys like survive out here. It's like noon is my lunchtime. Okay, so yeah, there was. So you can see, actually, we didn't change the name on this slide. There was a long discussion. No one could agree on what the name of this thing was. We call it protocol threat modeling, but it's a sequence. No, it's for APIs. So we just, being the good consultants, it's everything, right? But as I said, it comes down to these are things. They're sequences of events, of messages, of API calls that have to be protected. We can just go on. So in terms of the canonical attacker profiles, there are only two to worry about, since you're really worried about either the malicious client or the man in the middle. So because remember, this is not the whole system. This is just the interactions between any two components.
Right, so there are only two parties involved at a time, although you might be looking at a sequence diagram with like, 5, 6 different objects in it. At any point in time, there are only two parties.
Right, and you've seen sequence diagrams that do between there are multiple parties, but what you're always doing is you're always reducing it down to the exchanges between two. And so if like in an OAuth thing, your server might become the client to somebody else. You can see here we have a sequence diagram. You can see we draw the message exchanges. We annotate the, can you go back just one slide before?
Yep.
Yeah, we annotate the exchange with the messages and message data.
And the same thing, the message usually are the assets that is what protecting. Exactly. And then these are the things, the type of contents that are in the message.
Right. And you can see here, then we also annotate it with the controls.
Right.
So like here we're encrypting the password.
Yeah, only one type exists, right? Yeah. And the attacker profiles, like we said, there are only two.
There are only two.
So you can figure out what's wrong with this protocol, right? If you want to take that as a homework.
But what you can see here is that we use the same threat structure, but we applied it to a different system structure, which has been very powerful. Yeah. Yeah. Oh, and then you create the threat table from that. So it's the same idea. So the process is really the same, and what changes is really how you do the system analysis. And that's why I was saying up front, the harder part about threat modeling in this way is really doing the systems analysis. But if you're getting the development team to leverage, if you're leveraging the development team, they're doing a lot of that heavy lifting for you.
Right. So yeah, we're going to conclude with a couple of learnings and the next steps, and also we're going to open it up for Q&A. So from my side, the next step is one is for the metrics, right? The management likes metrics, like what's the return on investment. So we're starting to measure like how many teams are doing this, how many projects have been implemented with this. And scaling the training, right? We have like multiple locations in different time zones, and travel sometimes can be difficult, and a one day call sometimes is too long. So how can we scale that? So we've been experimenting, like, can we chop it up into smaller courses, and can we do it at kind of like both learning and doing at the same time? So we're experimenting different approaches to that. And of course, the coming up with these simplified system diagrams by the product team, the software engineers as the basis for this is our next step. And it is valuable, but it is different projects benefit differently from this. As we usually categorize the different projects into like high, medium, low, and for the medium and high, this is kind of like a mandatory. If not, then we will make a suggestion. But the point is that there are also other ways to secure a project.
But you're still taking the lead. Your last point of the security taking the lead that's pretty important. When we were building the slides, I thought that was a key thing.
Right.
It's like you can't just say, poof, here you go.
No. Right? You have to teach them, and also you have to take the lead to start get the practice going.
Yep. So for me, the protocol threat models I think are key. I think one thing is that it allows us to look at the system early on and in a level of detail that even DFDs don't let you get to. The sort of the generalization is don't really get hung up about how you represent the system, whether it's a DFD, whether it's whatever representation. Let's see, hung up. What's the colloquialism here is what? Not getting your knickers in a twist? Is that correct? Okay. So that I think it's and the last thing is really building it around the development artifacts. It's like kind of going with the flow. Don't try to create something that's not already there. Leverage what you have. It creates a better relationship with the developers, and I think everybody will be much more productive.
Right. In the end, it's pretty simple, common sense. Right. There are only three actors involved: like attacker profiles, assets that you're protecting, and what's controls that are protecting the assets.
And you juxtapose.
Yep. So with that, any questions?
Okay.
Thanks. In terms of your training, I take it you're looking at all your teams, all your architects, literally everybody will have the same level of training.
That's a goal. Yeah, we're doing it, business by business. So we start with some business and start training them, and that's ongoing process.
You mentioned about cross-boundary, so you've got teams in different parts of the world.
Right.
How are you coping with that? So obviously you're not going to be able to roll it out. You roll it out in one team and the interactions between
right. So we are building this community of instructors inside the company. So I'm one of the first batch of these instructors. Like Scott personally trained us, and then we train more people. So like there'll be like people in different time zones.
So it's a cascade out.
Definitely. Yeah. And we have to be careful not to dilute the content or alter the content too much along the way. So
yeah, we tried to convince Intuit to hire Digital for all that, but they were like,
oh.
No.
Yes. Oh.
You said I think you said you don't put in your threat table threats that you already have controls for.
Right.
So do you keep track of that somewhere else?
Yes, we do. We keep track of in different ways. One in the threat model document, right? So these are the missing controls or the weak controls especially. And also we keep track of that in the workflow system like Jira. So that becomes like a requirement or technical debt for the dev teams so they can work off the list.
But you could, I mean, so they use their threat table, you know, the process we use at Digital, we have a thing called, I don't even know what we call it anymore. It's changed its
Traceability
name.
matrix?
Traceability matrix. See, it's much better at it than I am, man. Yeah, the traceability matrix, it's really about, for me, the traceability matrix is about residual risk. Right? And I think the reason that they don't put things where the control is sufficient in it is because that table is going to development, and development says, I don't care. I'm good here. It's not going to go into my bug tracking system.
Sorry, one other question. Do you have any automated tools that you use for this? You said you just use Visio for the diagrams, but you know, is there any link into your requirements tracking tools or testing tools?
We use what we have, so you know, Visio and Jira.
Oh, right, okay.
Yep. So there's one in the back, I think.
Thank you. Thanks for the talk. In my experience, one of the things that makes threat modeling really hard is to come up with threats that are relevant to the system. So to identify not just a bunch of threats, but only those that are relevant, and to know when a threat model is good enough to be used. Have you done anything in particular in this work to address that? Because it's not an easy challenge.
Yeah, I think that in one of the things that's built into the system is the assets and controls do help. The threat actors is really important because the threat actors or threat agents, or what do you call them? We call them attacker profiles. So we have different names for them, but anyway, that helps too, because then you can start classifying. You can say, I don't really care about the insider threat. Okay, this person in the data center, very low, I don't really care about it. And you can go back to the business. Now you have a way of talking to the business about relative priority. Yes, you're dealing with a problem that there are an infinite number of attacks, and there are an infinite number of things that can go wrong. But because you have assets, which you can apply some quantity to in terms of the impact, and you have attackers, which you can say likelihood, now you have a way of at least doing some pre-filtering of the results.
Yes.
Because actually the metrics that you were talking about, looking to metrics, but also it would be really interesting to have metrics about when is a threat model good enough. It's not only about how many threat modeling have I been applying for how many projects, but also for one threat model, when is it okay? When should I stop doing threat modeling, and when can I use the results for a particular project?
Yeah, my experience at Digital is we just time box it.
Right. Well, yeah, we have to do that. I just recommend it to, like, you know, you do the threat model as a snapshot of your system, and at the end of the exercise, close the threat model, and for your requirements, you know, keep track of in the Jira or something like that, right? And then redo the, like, every whenever you have a major system change that will affect the threat model. There's one here.
The first thing you were doing was drawing your internal networks and all your applications. How do you choose what level of details to draw in?
Right, that's a judgment call, right? That's the hardest part of coming up with this simplified system diagrams of, you know, what's in scope, what is not in scope. So it depends on your experience and maturity of the team, and maybe you have more experience.
Yeah, I think that the answer for this group here at this talk is that's why the training, I mean, part of why you do it is because that's a field thing. The other rule of thumb I use when I'm doing it is I think about it like a lawyer. You know, a good lawyer only asks a question that he knows the answer to. I'm just kidding, but you're really trying to deal with, you know, it's going back to his question about how do you know when it's good enough. You want to start pretty high level, and then you're going to go, okay, well, I've got this. You know, you're not going to get anything too interesting, and so you're going to want to dig in. But what I think what happens with systems is that if you start with at a pretty high level, you're going to have a gut feel, and the engineers will have a gut feel for, like, well, that part is kind of critical, and you're going to, you know, so that's the conversation with the development team too. Yeah,
that's why it's super important to have the development be involved in this, because we don't know everything. You know, the consultants don't know everything. Security engineers don't know everything.
No, we know nothing, actually.
And not just development engineers, but also the product management and so on.
What time is it? Oh yeah, it's yeah. See, I used his watch.
It's about time for lunch.
Is it about time?
Any other questions? Last one, maybe?
Well, no. Well, thank you
All
very
right, well,
much.
thank you,
You've been a-
everyone.